All right, fair enough. Hey, everybody, welcome to the Service Mesh Performance community meeting. This is a CNCF project now. Service Mesh Performance has been a project for about a year. It has had fits and starts and various people involved over time. We've been fortunate that the community around it has been congealing into and beginning to harden the charter. Actually, the charter was a point of discussion the last time that we met, so we'll maybe recap that briefly here in a minute. But just as a point, as a little bit of housekeeping, so we record the community calls and have them posted on YouTube. Please be respectful. And with that, this particular call runs really similar to the rest of the open source projects that Layer 5 is heavily involved in or maintains. So that goes between, Service Mesh Interface, Service Mesh Performance, Get Nighthawk, Meshery, and there's a meeting every day of the week if you are so inclined. If you don't get enough bad jokes elsewhere, there's plenty going around here. With that, there's a couple of folks. So we also have a tradition on these calls to jot your name into the attendee list. For one, there'll be a random grab bag of annual gifts given out for the most attended or something like that. Or what's more likely to happen is eventually we'll all be fervently working toward a thing, and there will be, and we'll need to call a vote to maybe make a decision. And part of attending, part of what it means to be in the community and to be part of the project is to contribute. What does it mean to be a contributor? That doesn't necessarily mean code at all. Actually, so showing up is part of contributing, is just being active, being here. Sometimes we've had an individual in the Meshery community. He's been there for a year and a half, fairly consistently shows up, hasn't said one word on the calls. I've spoken with him. He's asked for mentorship and other things privately, but just shows up to the calls to hang out. And so that's great. So that counts is what I'm saying. Anyway, putting your name down is a good thing to do because we might have to call for a vote at some point. And that would come from people who are maintainers and contributors and et cetera. And so this counts. Okay, good. There's a great agenda lined up today. A couple of things to do also with respect to housekeeping and in following in tradition for these calls. And that is to, help everybody get to know each other a little bit. And so if it's your first time on the call, we ask that you just say hi, introduce yourself, tell us what you had for breakfast, what your favorite color is. Clearly, we don't take ourselves that seriously. Although I'll say this before people start to introduce that the work here is actually taken quite seriously. There are more people watching what goes on here than most of you are probably aware of. There are a number of other service mesh projects that are nervous about the potential research being done here. Some of them are nervous in a good way. Some of them are nervous because they have some hidden issues that maybe they need to work through. And so, yeah, anyway, good. With that, if you haven't been on this call before, please take a moment and introduce. Say hi.
Yeah, I guess I will start myself. So I'm Pablo, saying hi from the northeast of England. It's very nice to meet you all. This is my first ever meeting with you guys. So yeah, I'm looking forward to learning from you.
Pablo. Oh, very good. And Pablo, for everyone else's edification, or what's your full-time focus, or what your field of study, or you know?
So yeah, I've been in the data science field for around 7 years now. Before that, I used to be a university lecturer in computer science, and yeah, I'm leading a data science team at the moment.
Good. So I'll add to this because it's unfair to have Pablo do this, which is to say Pablo, well, might have a higher IQ than me, which, that's saying a lot. Actually, what I mean to say is Pablo's done some work in this area before. I'm really pleased that he's here because there's a number of things that we want to do around with respect to the application of data science here. There's a couple of you that are on the call as well. Navendu, I don't know that Dhruv joined us today. Nisarg, where's Nisarg? I was just talking to him. But there's a few folks who've been interested in some of the initiatives because it does have to do with some machine learning or some algorithms that we want to get into. And so I'm thankful that Pablo has something of a background or some amount of experience toward these use cases. And he can maybe show some of the, well, I'll speak for myself. He can show me the way in terms of how we might create some interesting things, some interesting analysis. So anyway.
And I think there's a lot of room to build great things. So yeah, very, very excited.
Good. Who's next?
I can go. I've been introducing myself at a lot of these meetings lately. Recently jumped in and started trying to be more active in the community. For those I haven't met yet, I'm Jared from Nginx, software engineer over there, working on the Nginx service mesh project. My main focus is more the QA side of things. I built out our internal test framework and performance test framework. So I'm really interested in what you have here. To be honest, what you guys have looks better than what I built out. It's so many different projects. It's hard to be able to focus on one specific thing sometimes. But yeah, it may just be part of the community and help out where I can. And glad to meet you all.
Nice, awesome. Yeah, I'm stoked. I'm pumped. Yeah, Jared, there's a couple between. I hadn't even considered it, but I was just kept thinking about SMI conformance so much, and then, but yeah, very clearly, SMP, and the two are related, SMI and SMP. There's a diagram showing that overlap. Actually, we should bring that up at some point. But yeah, good. Anirban, I don't know if you've been able to join this particular call before.
Hi Lee. So no, I'm attending after a break, and hi everyone. And I was part of the VASM, but as I said that I did not have a background on containers, and it was quite tough for me to stitch in the. So you are back. So basically, I am back after a short break. I had developed something on the VASM, but it was very difficult for me to stitch with the Docker Kubernetes stuff because I personally have no background on the containers. I'm still learning on that side, so it was quite tough. And as I told you that I'm very much interested in a pure C++ kind of environment where there are not other things to be taken care of. So I'll be willing to contribute here. I might not be able to attend all the meetings due to clashing of some of those meetings, but definitely I like to contribute over here. Thank you. Yeah.
Beautiful. Who else? So Suhani and Zain, I can't remember if the two of you have been on this call before.
Yeah, I was on call, but I hadn't introduced myself last time. So hi everyone, I'm Suhani Agrawal and I am DevOps engineer. And I started contributing to Mesh in July, and everything is new for me. So I'm learning it and I'm liking it here. And yeah.
Nice, good. Actually, one thing to highlight that Suhani's been involved in is interactive labs that we'll highlight that allow people to get their hands on SMP. This is a good reminder. So on the SMP spec site, we don't currently have any interactive labs, although there is an interactive lab already for SMP specifically. It's not up here, and it can be easily made to be up here. Is Vinayak on? Mr. Sharma?
Yeah, I'm on the call.
Oh, very good. All right, good. So between the SMP spec site and the get nighthawk.dev site, we might want to consider embedding one or more of these potential labs so that people can understand how to run a test in concept, alongside SMP, or run a test using Nighthawk.
Yeah, that
Suhani,
would be really great to have, I guess, on the Get Nighthawk website itself.
nice. Okay, good. So anyway, by way of introduction, so Suhani's been focused on those. That's nice. And then I forget who else it is that should introduce.
Okay, can I lead?
Yeah, please.
So hello everybody, my name is Zainbin Abdul. I come from Kerala, India, and today marks my 2-week anniversary at Tamashri. So I joined here 2 weeks back, and I've been trying to contribute towards the front end as of now, but trying to shift towards the back end because that's where I like more. Yeah, that's all from my side.
Nice, awesome. Very good. Who else? And you are all welcome to do so in chat as well. I realize it takes a little while to kind of go through everybody, and so, but it is. It's really important. It's really important for folks to be able to connect. It's like that's half of being part of the project. So there's a couple of. We're fortunate that I think there are 5 or 6 service mesh performance maintainers, SMP maintainers. I don't quite recall, but there's about 4 of them on the call today. And so Otto van der Schaaf is on the call, currently at Red Hat. We'll hear from him and just actually probably first up. Sunku Ranganath is on the call as well, currently at Intel. And I don't think we can not hear from him. He always has an opinion, which I never get a chance to razz Sunku. So this is my only chance.
It's a nice introduction of me.
Yeah.
Thanks.
Navendu Podakat is on the call. Utkarsh Shrivastava is on the call. Good. Okay. Hey, with that, let's. So one thing that Jared was noting is that there's a lot of stuff going on. And that's intentionally true. There's a lot of things to cover. We're going to talk about a couple of projects today, both SMP and Get Nighthawk, and maybe even spend a lot of our time toward Nighthawk if we can. There's just a lot to comprehend. On that, Otto, do you want to do the honors there? Kind of talk about just Nighthawk itself, and then some of its ability to be extended.
Sure thing. So first, hey everyone. For those who I haven't met yet, my name is Otto, and I've been doing a lot of work on Nighthawk in the past period. So Nighthawk, in essence, is like a tool which is capable of generating load on multiple protocols, HTTP 1, 2, and 3. Well, it has a particular focus on being sensitive enough for measuring microservice proxies. So having said that, that's kind of like one of the big rationales for why Nighthawk came to be. And today I wanted to also spotlight something that comes with Nighthawk, and that is like a separate component in its repository, and that one is called the adaptive load controller. So first I want to back off a little bit. I do need to sort of give a heads up. I haven't been able to prepare this as much as I'd like to, because there's like zero documentation for this right now. And I know actually I was under the impression that there would be at least some from the design documents around that would be useful in like a presentation, but that's from a previous gig that I worked at, and that's not cleared for publishing yet. So having said that, I have been involved in all of the reviews of the adaptive load controller, so I'm gonna try and give like a high level description of why it's a cool feature and how it works and how you can extend it. So with most load controllers these days, you can do like, two types of testing. Usually it's kind of implicit. Most of them send like a bunch of static traffic, and then either, do allow like back pressure of the server and call that closed loop. And others do not work with back pressure. They work in open loop mode, and that's a little bit more realistic, probably. But while that's pretty useful, that doesn't really it often doesn't correlate to like a question that someone who operates proxy or even a mesh might have. I think that the like a key question one would have is like what kind of hardware do I need to sustain this traffic profile at this frequency while maintaining a certain SLA, where that SLA mentions like a maximum latency and says something about maximum error frequencies and all that. That's kind of like I guess a question that is really interesting, and this is where the adaptive load controller more or less comes in, because that likes sorry, the adaptive load controller is like automates like iterating, searching that optimal request per second amount according to a traffic profile, while seeking like convergence on that. And it gives you like the current maximum amount of requests per second that your mesh or system is able to sustain. It charges that for you. And that's like what the stock implementation that comes with Nighthawk out of the box does. And then I say a stock implementation, so the reference implementation works with Nighthawk, but most of it is extendable. And so, if you want to, you can make this work with any other load gen, or you can even probably find completely other purposes for it. So yeah, that's like a high level description of the adaptive load controller system. Now, as I understood it, there may be some people on the call who are interested in materializing specific goals with it. Now, what I can do is like attempt to walk through the code over here, but I'm not sure if that's desirable right now, because that might consume quite a bit of time, and I'm not sure how many topics we have to go through in this. Lee, what do you think about it?
Yeah, well, or maybe if nothing else, to just to highlight where people might start to read through.
Oh, sure.
And
yeah, before I can do that. So before I share my screen, there's also one other thing that I wanted to point out. I mentioned it in the meeting notes, but this was built in a collaboration with a team within Google, and it is very likely that one of them will be presenting in way more depth than I'm doing right now on this system. So that's something I wanted to point out. Now, let me try to share my screen.
Question. So while you're sharing this, I think it would really help to kind of understand open loop versus closed loop, the main differences, and how we test this, because some of my colleagues internally have been leveraging or using Nighthawk, and the details or understanding of like what's the main difference between two is still this lack of clarity there. So it really helped to briefly go through.
Sure. So in closed loop mode, basically the pacing at which a load generator releases request is influenced by the speed of the server. So I think that's the key thing. And in open loop mode, there's no correlation between whatever the server does and the frequency at which a load generator releases requests. Does that make sense?
The server being the Nighthawk server or the physical server?
Sorry, the test subject. Sorry, yeah.
Okay, and the speed corresponds to the frequency or the response time. Like how do you quantify that?
So when I configure Nighthawk to release 10 requests per second on a single connection, then that connection has to be free all the time, or at least it has to be freed up timely, at least every 1/10 of a second, for Nighthawk to be able to release a request on that single connection. Because if the test subject takes too long to respond, then the connection isn't free, and the Nighthawk has to respect like the server, wait for the connection to free up before it can send a new request, right? Mm-hmm. So that's kind of what I'm calling back pressure here. Now, in open loop mode, yeah, given that you're not resource constrained on connections or anything like that, Nighthawk will not consider server response times at all. It will only respect the pacing and that you configured, and if the server isn't keeping up, it will either open a new connection or it will register an overflow.
Got it. So essentially, you're considering HTTP response times based on the number of connections, or would it be the TCP response times? I mean, TCP connections.
TCP connections. Yeah, this operates on the connection pool level within Nighthawk.
Okay, got it. So and the 1/10 of a second is your metric, essentially, after which you start load balancing in that sense.
I'm sorry, I'm not sure I understand. Can you help me?
Yeah, sure. So the metric that you determine after which you start, what's the term? Like controlling the load is 1/10 of a second response time. I mean, so the back pressure, at what level, right? So you mentioned 1/10 of a second. So is that the metric that you chose to kind of figure out whether the connections are if there is enough back pressure or not?
No, the 1/10 of a second is kind of an arbitrary value. I'm trying to like set up an example. So this is a hypothetical scenario where you configure your load generator at 10 requests per second.
Okay, but in reality, so when do I know, or how do I know, that the load is being, throttled?
So okay. So with what the Nighthawk client does is track like a separate histogram, and in that and that histogram has values that correspond to the amount of time that the load generator spent waiting on resource constraints. So if it was time to send a request, but there were no free connections to do so, it will then like track when that started and when that ended and register that time in a histogram. So that's as soon as you know that histogram starts showing up with blocking time, the more blocking time it registered, the more or the less sense your results are actually going to make. And this is specific to closed loop mode. In open loop mode, you'll be seeing overflows. It will just skip. So in open loop mode, it probably makes much more sense to just configure these resources to not be as constrained, because in either cases, you don't want to see blocking time and you don't want to see pool overflows and that sort of thing in your test executions, probably.
Okay, got it. The reason I ask is for something like RFC 2543, I think, yeah, may be wrong with the numbers, but yeah, anyway, the layer 3 performance testing, the RFC for performance at layer 3 testing suggests that you follow the binary search algorithm where you start sending traffic 100% and you see the losses and overflows, what you suggest here. You scale back 50%, that succeeds, go up to 75, that succeeds, and then midpoint like 75 plus 12.5. So it's a kind of like a binary search algorithm until you come down to the parameter that you set for the testing, which is 0 loss or 0.1% loss or 99.999% success rate, something like that, right? So until you reach that rate, there's a binary search algorithm. So I was curious how what kind of algorithm you follow here, and it seems like you're mentioning you have a histogram of this loss rates or the lack of connections that you're looking at here, and at some point, which is what the adaptive nature that you're sharing here is, that it'll adjust accordingly.
Yeah, I think you could like wouldn't even be that big of a modification. You could extend that adaptive load controller to seek convergence based on these overflows or blocking times that you're seeing. Yeah.
Got it. Okay. So when you say resource constraint, that can, I'm not sure if that's the right term, in the sense like that can open up a big can of worms from the perspective of hardware resources to Nighthawk, or software resources, or RAM, or is there any contention to the Nighthawk application at the load server, right? So it can be multiple different things when you say resource.
Yeah. So So when I say resources, it's actually one of either connections or maximum streams, that sort of thing. That's from the top of my head.
Got it. Okay, thank you.
But there's more, because basically this translates into Envoy's, what's it called? Sure, I'm lost for the term, but it translates into an Envoy concept, and I actually think that's where the term resource also comes from. But yeah, I agree that it's not. It's a too generic of a term.
Yeah, got it. I mean, this is really good info in a sense. Like, I think if you put it down in a blog or any other document, like few pointers, how with an example, that'd be, I think, very valuable to the community.
All right. Well, point taken. I'll, I made a little note of that. So, well, okay. Now, as for the code of the adaptive load controller, I think the best entry point to start, glossing over how it's stitched together, so to speak. It's actually this. It resides in in the Envoy proxy / Nighthawk repository, and then there's a directory called source / adaptive _ load. And that's like where everything implementation wise lives for the adaptive load controller. Well, and then the entry point is adaptive _ load _ client _ main.cc. And what happens in this file is basically, takes reads like the command line arguments that you give it and passes that to an adaptive load controller concept called the adaptive load controller. So this is basically where, I think the rubber hits the road right away. So arguments are parsed, and here it translates the argument into one of the proto APIs, the top level proto API to configure the adaptive load controller. And in this specific method, it kicks off the whole process. So what this does is it actually doesn't use Nighthawk's command line tool to as a means to generate load and iterate on configurations. It actually sends repeatedly sends proto messages to the Nighthawk server, which in turn will do the load generation. So that's kind of good to know. So that's why it's generating or creating a gRPC channel over here and generating a stub.
Question about that, if I could insert a question about that.
Sure.
And if I'm jumping ahead, just ignore it. Is part of that communication that through that gRPC channel, is that with each potential generated load and subsequent analysis of that load, with each potential step through what might be something of a recursive analysis, is in terms of injecting or in terms of the analysis that can be done, and in terms of controlling when to step versus not, score, so there's, I'm going to confuse a lot of things probably and throw in, but if you're more or less performing analysis after you've run a generated load, and you have a scoring function maybe for that particular output of that particular analysis, can there be a large amount of time? Is there a control point there to could it take 5 minutes before to do that analysis and then come back? And are there any constraints with respect to time, I guess, for when the next step would be taken?
So are you referring to a pause between different steps?
Yeah.
That's a good question, and I'm really sorry, but I can't answer that on the spot. I don't know. And actually, I'm kind of pessimistic. I think it will just immediately go to the next step. It's not a thing right now. It doesn't sound like something that would be hard to add, though. But so yeah. So one other thing that got mentioned was horizontal scaling, which obviously intersects with this, and horizontal scalability still is in flight, but it's quite close to actually being done. And there's one thing. So when I look at this, there's one thing that I need to do, because at some point I promised that, but this talks to the gRPC servers, and there needs to be either a small tweak to this file, or like a sort of a translation service between the adaptive load controller protos that get emitted here. The messages that the adaptive load controller sends out to request load generation. Ideally, that was the original idea, and it still is with horizontal scalability. The way Nighthawk implements that is that it's like transparent to either the CLI or, in this case, the adaptive load controller. So, I'm gonna make sure that we actually don't require any changes here. I'm sorry, I'm kind of seeing this and it comes to my mind. I just want this to work when horizontal scalability lands. So,
yeah, another.
Well, I think this is like the absolute top level. It's not a lot of detail. If anybody has like specific questions, I'll be happy to try and answer them.
Here's one. It's high level as well, which is for if I can use the term. So we're looking at a reference implementation of. Well, and I'll try to use these terms consistently, and maybe we'll, through our use together, maybe we'll solidify some of these. But so actually, can you say, Otto, this is a reference implementation of an adaptive load controller, or this is a reference implement?
I think it's like the whole thing here is like a reference implementation of the adaptive load control system. There's like interfaces too associated to that. And at some point, I think you connected like this system towards reconfiguring a mesh on the fly. Is that correct?
Yeah. And that's kind of what I was going to ask. Is that for those that are writing extensions, or those that are writing? This is where the terms, for those that write a different implementation of an adaptive load controller that write what's more or less an extension to Nighthawk to like plug in a specific set of analyses or a specific set of steps to go through and scoring functions to use. That do you know, are those dynamically loadable, or does one need to build,
No, they're not dynamically loadable. So you should probably, I don't think they're dynamically loadable. So everything that you need has to be built in, unfortunately.
Okay.
There is WASM these days, but I'm not sure how easy that is to plug that into Nighthawk for these extensions. So, but that might be worth something looking into, but I'm not sure how much work that will be. But before this meeting started earlier this afternoon, I did, in light of this, I did look a bit at like the interface of Nighthawk, and so the interface of, all interfaces, and I'm talking like C++ interfaces, not proto interfaces. Sorry, they reside in. This include /Nighthawk, and so what we need to do is maybe go over this, because we're diving a bit deeper right now, but this is we need to check like this interface. We need to propose something to make that a little bit less specific, because now it's, there's stuff in there that ties it specifically to Nighthawk. Like, this proto message. And that's suboptimal in light of what we want here, I guess. So that needs looking into. So, I haven't, looked in that much detail in it that I'm gonna, that I have like a gut feeling of the amount of work that it's gonna be, but we should, probably follow up on this and flesh that out and scope that out to see what it takes. So I'd be up for helping with that. Because I think when you look at the adaptive controller, this adaptive load system, and you zoom out, it's not what it does isn't really specific towards Nighthawk. It shouldn't be at all, or a load generator. It's just reconfiguring something, and analyzing results. And if you can abstract away from all the inputs and outputs, then it's a pretty generic system, and it could do what you want.
Who else has questions on adaptive load control? So I'll say this, that for my part, I'm really excited about this area and the potential to bring some extensions or the potential to ask a set of questions and have them answered through use of the adaptive load controller. There is, if we go back to the community meeting minutes for a moment, just sort of one, noting the time, and then two, understanding the state of this particular spec, that it's probably not appropriate to go through this spec at the moment, but what would be really nice as people familiarize with that reference implementation of the adaptive load controller is that we begin to articulate a few questions that we would like to see if we can answer. And to Otto's point, some of those questions, at least from my perspective, are about helping people run, in context of a service mesh, specifically. It doesn't have to be limited to a service mesh. I think, and that's actually part of what we've been discussing about the charter of service mesh performance itself, whether or not the focus should be constrained to this particular niche or not. That was the subject of conversation last meeting. Is that like some of the questions that you can, I think we should articulate some of these questions fairly well, see if the existing adaptive load controller framework, that system is well positioned to be able to answer these things. Some of the, like an example question that some of you have probably heard me say before is like, it follows on what Otto had just articulated, is that a lot of times people will grab a Nighthawk or grab Nighthawk to answer a question like, to understand and better right size maybe their infrastructure for either financial savings or to guarantee a certain SLO. And there are any number of considerations to understand there. One of those is about latency and trying to achieve a certain latency or guarantee a certain latency without necessarily overpaying for it or without necessarily not having your infrastructure as resilient as possible. Like, I think you could add on any number of additional constraints to that question. And that's actually one of the things that I'm hoping that we might be able to answer with an adaptive load controller. That is to extend that question is, how much horsepower does my infrastructure need to maintain a specific latency profile while at the same time maximizing its resilience. So if a service mesh is part of that infrastructure, and you can use a service mesh to help you with the resiliency of the way that your services are running. And the specific example here is if one service tries to communicate with another one and it has problems doing so, it might need to back off for a moment and go ahead and retry that request. Maybe it should do it a couple of times in case the other service was busy, in case the network was having a thing. in case there was a DNS thing, in case whatever is going on, like you want it to be resilient, you want to try it a couple of times, but at some point you need to stop. And you can go statically configure your service mesh to have such a configuration, like to have such a resiliency configuration. But as you take just those two components of this type of an equation, like I think that that's a question, or I hope that that's a question that we might be able to answer using adaptive load control and running a series of analyses to be able to say, hey, here's the maximization, here's the optimal, here's the maximization function for your configuration specific to your environment with your applications according to the maximum latency that you're willing to sustain. Here's how resilient your infrastructure could be. And then next week, when they change something and they add a new service, well, we need to run that again. Oh, great. That being an example of something that needs to be articulated in written form about like that question, along with any more. And so this particular document that I'm taking the Vendu's thunder, because I don't think that it's really ready to go through, but I'll just call out that there's a doc here that we, the community, all of you, like this is a good, consider this a solicitation to articulate the questions that you might like to have answered using that example, or does anyone else have an example off the top of their head?
Yeah, one thing that would help, in my opinion, is having a way to understand when the scaling happens, scaling in the sense when this adaptiveness, so to say, changes, either in form of ability to, I think that in the code you have a way to log these changes. However, in terms of what kind of granularity would you be able to modify it or provide it a parameter to change it, right? So something along those lines would be a really help.
So when you say scaling, do you mean scaling of the infrastructure or scaling of the load that Nighthawk is generating?
Right. So more in terms of the load Nighthawk is generating, in a sense, like so if you want a repeatable set of tests, right? So to understand whatever's happening on the server under test, device under test, so you need to know how much load am I generating and how much it's changing based on whatever's happening on the device under test, right? So from that perspective, if I have a way to control my adaptiveness, or if I have to way to understand the adaptability, so to say, right? So that would kind of provide me a deterministic mechanism to say, okay, under these constraints, or if I have like 10x the TCP connections than the first test, the load changed in this format versus 5x the connections to the first test, the load changed in so and so sequence, whether it's time or whether it's the number of connection, the HTTP connections or transactions per second within those connections, right? So to have that deterministic way of understanding what's going on, you need to know how this adaptiveness is changing based on the load or the back pressure, so to say, right? So I'm not sure if it's straightforward today. Am I making sense?
So can I'm gonna try and summarize or at least rephrase what you said. So to check if I understand it. So are you suggesting like we run like the same amount of traffic, but then with, for example, different connection counts, and then see how that impacts throughput?
Right. So I guess the adaptability in the closed loop mode here is that depending on the back pressure. So if I have 100 TCP connections and 10,000 HTTP queries per second, and it might have so many losses based on which the Nighthawk load would change, versus say if I have 80 TCP connections and on top of that I have 10,000 HTTP queries per second, my load from Nighthawk would change, right? Because the number of failure rates or whatever other parameter you consider to change the load would be different. And unless I have a way to kind of measure or understand or know how much how Nighthawk is changing the load, my two tests are not similar. My failure rate that I measure or the queries per second success rate is not necessarily similar, because the load being generated is different in the two cases. And obvious choice, I can go to open loop mode and not worry about all of this. But in a closed loop mode, if I understand my input, then I can quantify my output, right? Change in my input versus my output.
Yeah.
So I'm thinking it's not straightforward today to understand, because it's based on a histogram of responses, and it's not necessarily. So how easy is it to understand how the?
I do think that Nighthawk is able to quantify. So it's able to quantify how much time it spent waiting on the server in closed loop mode. So it can quantify that for you. It can also quantify error rates, but having said that is something that, and you could, like, it would be probably be a small tweak to the adaptive load control system to write an extension to consume that time spent being blocked, and consider that in its input while it computes its new configuration. So I'm not sure if that's if that would be helpful for you, but I just wanted to float that.
Yeah, I mean that can open up multiple opportunities from a load testing standpoint if you're able to configure that input in a sense, like you're tweaking how fast or how much of the adaptability you can control that aspect of that adaptability, so to say. That's really a great option if you can. The other side of it is from what you mentioned, you can quantify this changes. So that, I think, it's a really good first step to have a clarity either in the logs or in the output results to say, hey, here's the back pressure, here's how much I changed. Just in the output results, that would be a really great first step.
And I think there's something else that's also possible today, is that you can configure, like, Nighthawk also in its service to propagate, like, everything it tracks to I think Prometheus or something like that. So you can track it over there as well. So well, it's probably needs visual inspection, which is not optimal, but you can, with that, you can have a way to at least inspect, like, what happened during the adaptive load control sessions to see, well, if something funky was going on with respect to too much back pressure, for example, or something like that.
Great, that's awesome.
So Otto, we're almost at time, but will you say a little bit more about Nighthawk's integration with Prometheus?
So I have to owe you that one, because I didn't write it. I did review it, but it's so long ago, so I don't want to say things that aren't true. So
yep, sure. Zane, Zane, is this your email address, by the way?
Yeah, it is.
Okay. I don't know if this may not. I don't know if this isn't something for you to potentially have a look at, just as an educational thing for all of the rest of us. I assume that Nighthawk has using the Prometheus client, like Methius ++ client, to be able to expose metrics in the Prometheus compatible exposition format so that a Prometheus server can scrape those metrics, like probably leveraging something very similar to what Envoy is doing. Ping me after the call if that is completely foreign, and we'll.
I'll try to find dig up some information too when I have my hands free. So
As we track toward the top of the hour, other items that we need to cover today. There's a few that we didn't get to, but does anyone have something we didn't cover that can be quickly covered, and then B, things that we need to talk about next time?
At the risk of taking up others' time, I have a couple of points. So one, I think that Otto mentioned that Google folks can come in and explain in depth. Do you see that happening anytime soon? I mean, is that being coordinated?
So obviously I have no control there, but my hopes are up that it will be by the end of, probably by the end of this month, before the end of this month. So I'm optimistic about it.
Great, thank you. So another future topic from my side is about test cases and what kind of testing we could do in terms of overall mesh testing. Internally, we've been going through some of the scalability tests or scale out, scale up kind of tests. So possibly it's something I can share at some point.
So is it appropriate or inappropriate to tag the word benchmark with the thing that you were just saying?
Yeah, benchmarking would be the right term. Yeah.
Okay. Yeah, nice. Good. Good. I'll try to tie up the notes here. It doesn't, by the way, just on these calls, I know the project and the community around it is somewhat young, and so we've yet to hit just a consistent cadence, but we're getting there. Today's call is really great. There's a couple of folks who weren't able to make it that I know are interested. I bring up the cadence and things to say that for my part, or there can be other hosts of this call. Like this isn't, and that doesn't need to be me. And yeah, Otto, it'd be great if, I know Eric is something of a linchpin for part of that next discussion. We'll also hound Jacob a little bit to see if, I know he's not one for meetings.
No, but
but there's a real opportunity for I expect some of the work that they're doing here. So,
I think that it's it's an opportunity in the sense for that work to get some spotlight, and I think it's a pretty cool feature. So,
yeah. Nice. Anybody have anything else for today? Next time we meet, I think last time, Nivendu, you talked a little bit about KubeCon, but that's a great topic for next time as well, and will be timely. We'll probably, prior to meetings, send out some activities that all of you can potentially be involved in with respect to service mesh performance as a project and KubeCon, and telling people about what we're doing. So. Very good. All right. See you all in a couple of weeks.
Right.
Okay. Thank you all.
All right. Well, bye.
Thank you, Otto.
Thank you.
Thank you, Otto.
Thanks.
Bye.